So we can start. And with this lecture, we've sort of finished the stack of protocols, which is, I understand, probably a little bit boring. And then we will start from next lecture to talk a little bit about discovery, and then finally with design of these service-oriented applications. But for today, we'll continue with the description part. So that's the usual picture about our stack. We have been talking about the messaging last time, in particular the SOAP protocols. And now we go, the description is in particular, again, not only one protocol, it's a number of protocols, but the most important one, and the one which is used most, is the so-called WSDL, which is Web Service Description Language. So that's the problem that it's tackling. It's giving a kind of a solution for how to make the service invocation, how to allow distributed application to know how to call a distributed service. And the outline of the current lecture is as follows. First, we'll talk generic information, just the idea of what is a web service description language. Then I would like to go into the detail of a skeleton or a simple document of WSDL in order to present to you all the various elements, both at an abstract way and then in the actual implementation of a simple example. Why this? Well, because even if it is true that let's be honest, you will never write your WSDL document, essentially. You always press a button and the compiler or the engine will do it for you. It's interesting, first of all, to know how it is done from two points of view. One practical one, you need to know what's going on, and you need to know how your message and your interfaces will look like and how this is implemented. And this is always good to know what's all this machinery and middleware and compiler do it for you. On the other hand, it's also interesting because it is a very, let's say, interesting best practice for protocols development. In particular, WSDL has been really very successful, and the reason for this success is that it's simple, it's clearly built, as we will see, it has a clear architecture. So I and in general, we think that it is important to have a good grasp of the structure of the WSDL document, because it's an interesting, let's say, protocol also for the development of other protocols eventually. As we will see, it's very popular to develop new protocols and agreements essentially between services. We will also talk a little bit about exchange patterns, message exchange patterns. These are part of the WSDL structure, of the description of the WSDL structure, but we'll talk a little bit in particular, and then a little bit about WSDL usage, although it's clear that the majority of this will be done in the laboratory with real examples and, and tools. So, Web Service Description Language, pronounced WSDL, or WSDL, if you want to do it more correctly. What is it? Again, it's a specification of the 333 organization. And if you want to know more about all the things that I will be telling today to you, if you want to go into the details, there's the link. It's the description of the specification, very comprehensive, obviously very updated. And you will find everything, I hope, and more than I'm going to tell you today. But I hope that what I'm going to tell you today doesn't essentially So you don't have the need to go and read these specification documents, because we are going to cover the important concepts that are going to be there. Obviously, it is machine processable. That's the important thing. So it's a description of the interface of any services, in particular web services, and it has to be, it's done not for humans, although, as we will see, reading a WSDL document, we as humans can understand. It's not something that it's completely crypted. We can understand. It's clearly much more verbose than what we would use. Between humans, we just would need probably much less information. It's very verbose, as all these XML documentations, in order to be able to deliver and to convey all the important information between machines. And essentially has two main, let's say, aspects. There is a description part, obviously, it is a description, and then it is done in such a way that all these descriptions are expressive enough for a program, for some kind of tool or server on both sides of the client and of the servers to create automatically the so-called client stub, so the so-called the proxy that act between the web service and the client. This is how it looks like. Just like with SOAP, there is an internal structure of the protocol, of the specification, and the most important, let's say, difference, the most important part of this structure is this distinction between two parts in the WSDL document. There is a so-called abstract part, which is the one that tells the user, a machine very probably on the other side, how to implement the interface, how the interface of your service looks like. And you can imagine what you have here. Those are essentially the main components of this abstract part: data types, how the messages between the two objects, client and servers, looks like, how you combine together these messages into operations, and how you finally put it into a so-called port types. And then there is another part which is called the implementation or concrete part of the WSDL file. Let me say now, from now, when we say concrete, we never mean that it is the actual implementation of the service. We are talking only about the interface and how to invoke the service. The actual implementation of the service is done in a development environment, per specific programming language, and it's outside of the WSDL, which is only a file that it informs the potential user of the service about this particular service. When we are talking about implementation, is the details that has to do with the transport, for instance, and with the actually access point. So are we using HTTP? Are we using another protocol? We will see this in the details. This structure is particularly interesting because it really separates, is a very well, let's say, design of the protocol, because it separates the design part, which is the abstract, so just how it looks like, how you want to talk with the service, to the deployment environmental details, which are more engineering details. Then, again, there is the programming part, which is outside of the scope. You do the programming with whatsoever language and development environment that you want to do. That's the part about the two parts, and this is, we'll go through this in some details. I mean, I don't want to do too much, but that's more or less the elements hierarchy of the WSDL specification. I'm going through the WSDL specification, which is version 1.1. So the names that you find here are, in some sense, the old names. And now there is version 2.0, which is an evolution of version 1.1. So as you see, together also with SOAP, there are not too many evolutions about the protocols. The specification. With WSDL, we are at 2.0, so there have been some improvements. But in general, this structure is the same. It changes a little bit the names of the operation, but not important from the conceptual point of view. So this is done following the pictures as before. On top, we have the service interface, so the abstract endpoint typing. There is no information about how we want to transport and how we want to encode the messages. Then from this layer down, a different layer of specification, you go into the service implementation, in which you include information about this transport, encoding, network address, and eventually physical, meaning URI endpoint instances where you can really call and the service. And you can attach your own program to this particular service. So let's focus first on the abstract part, the one related to the service interface, and let's do a little bit let's go into the details of all these elements. It's a hierarchical elements way, so you start from the small atomic, let's say, elements, and then you keep on combining them in more complex structure. So first, we start, let's say, for the sake of doing an example, let's use the same example that we have been using also in the SOAP lectures and also previously. So let's say that we want to implement a very simple web service that offers, for instance, one operation. So in this case, we only focus, as you will see, on a number of details, and if you have more functionalities, like more operations or bigger web service, you just have to add more information for each of these ones. So this is only one very simple service, one operation, and it's essentially a remote procedure call, just to make it more simple. We are interested to a service, to describe a service that implements this kind of operation. I send to the service a symbol through this particular operation, and the service retrieves me with the current value of the stock quote, in this case, as a double, so as a number. So first of all, we start writing WSDL with a generic parent node in the XML file, and all other elements are inside this one, and the node is definitions. And the first things that we have to do, we have to connect with global namespaces about prefixes. Here there can be as many as you want, depending on your application. In this case, we have essentially only two. One is the WSDL specification, which is that one, second one, and then we have also an internal schema, which is probably related to the data that has been that we need to deal with. In our case, it's very simple. In this example, it's very simple. And that's the. I'm moving too much. And that's the definition. Inside the definition, I'm going from the picture. In reality, is top down, but in reality, I'm going bottom up. So I'm starting from the more, let's say, specific atomic elements, and then building up complex element. So the first things that you encounter as WSDL elements is types that essentially are used to define the kind of data that you deal with in your services. So here is something For instance, like this, you open types, you close type, and you say that you are going to have something which is named stock quote. And the stock quote, I mean, this is essentially a definition of an abstract type. Is a sequence or is a complex type, is made of two elements. One name is a symbol and another name is a last price. What you find here is, again, this kind of duality. You don't need to specify the details of the actual data that you are involved, because you have, in general, another document. It's this one, is your schema, where you can specify, is outside of WSDL, but it's referable, because it's also in a URI, in which you're actually explaining what are your data. So it is in the second file. It's the same that we have encountered in SOAP. Also in SOAP, you have the possibility to always connect to another XML schema that defines the data, the actual implementation of the data type. And that's the same trick that is used here. Here you only say that you're going to take something which is called symptom, something which is called last price, and you refer to this other schema, external one, in which you actually say what they are made of. And in this case, they are made of two strings, okay? And you can obviously create as many complex type as you want, but remember that you have these very simple things. All the scalar values, and then you have arrays, and then you have structures, essentially, where you are combining different things. Here is a wrong, right? The price is not a string, it's probably a double. Yes?
Are both those XML schema mandatory to be defined, or we can just define that one inside the WSDL and the other one outside?
Nothing is mandatory. The obligatory part is somewhere there must be, you must rely on a definition of the data types, on a description of the data types. This is one way to do it, which is to use an external file, and it's always, let's say, is the most favorable situation, because you are very flexible, you define your own schema, you have complete control of what are your data. The other possibility, which is the same as in SOAP, you can have internal default values for WSDL, and that's, they are also supported, and they are the same as the one done in SOAP. So you have always these two choices. Either you use the default one, or you use your own external one, and you build your own. Using your own is better because you have much more control, obviously. Next, if you remember, we have, well, the types were not even in the original figure. These are really very low-level elements. The first things that you have on top are the parts, and these are considered as you are essentially describing the messages that you are going to use in your services. And here are, for this particular example, three types of messages. One message is which very probably is going to be used as input for the service, in which something is going to ask you the symbol. And so you're going, is only made of one part. In the real cases, you can use as many parts as you want. You are defining the messages, so it could be only one parameter, more than one parameters, etc. And you can combine them together. For this example, we only need a message that is asking the symbol. We will have the message that is providing the price, which is the output messages of our service, and it's always good to have a message that provides an error message, so the default one. So input, output, fault, more than one, in this case only one. All the various messages are going to be described in this way, and each message is constructed for a number of part elements. Very simple. Now that we have the data and the messages, we have to combine them together in order to make our service. And following our example, in which it is just a procedure call which we are sending a string, and which is describing the stock price and retrieving the data of this one, that's a possible way of combining the messages. We have an input message, we have an output message, which was been previously defined in the previous slides, and we have an error messages. Now, the only thing to be careful here is that you have always to consider, in order to understand all these specifications, that you're always looking from the service point of view. So you are the service, and for you, you are waiting for an input message that is coming, and you are delivering an output message. And the output messages typically are, yes, I've been able to process the request, or no, I'm not able to process the request. That's the really, let's say, schematic thing. This is the operation. And then you wrap this operation. This is something that it's clearly understandable, it's better understandable, let's say, when we move to the concrete implementation. But you usually wrap this operation in what is called a port type. At the moment, it's kind of overloading, because the real thing that you are implementing is the operation. But the port type is a concept that it's very interesting from the implementation point of view, because you can define different ports, and you can attach one particular port to a particular transport protocol, another one to a different transport protocol. So it's kind of, and this is the typical things of WSDL. So you are essentially including and looping inside one of each other the various parts. So here is, in the messages, we are including the types, and then in the operation, we are combining together the messages. It is at this level that it's important also to define it is important, and it is also possible to define some standard patterns of usage of message exchanges. And the one that we have seen above, previous, it's clearly a standard remote procedure call, so it's a request response. And that's one of the type, one of the most used type used in web services. But in reality, there are some other ones, not many, but the current implementation of WSDL supports essentially 4 main message exchange patterns. And this can be essentially grouped into 2 categories. The one is the client generated, and the second one are the server generated, okay? It's again very simple. The first one that is the one that we have already described, is the RPC standards. So it's the client that requests something to the service, and the service that responds. Again, from client generated, there are also a number of applications which works with the so-called one-way, input only. So again, it's the client that generates something, the server, the web server receives it, and essentially does not produce any output which is sent back to the client. You can think as an application for this particular kind of message exchange, the sensors. So a sensor is producing some data, and it's sending the data in a one-way message exchange patterns to the server. If the sensor is not very, let's say, smart, does not have the possibility to proceed or to process, let's say, some messages that are back. It's just a generation of data, and there are many out there at the moment. Switching context, there are also some applications and some services in which the actual initial action starts from the server, so from the server side. There is obviously a problem in this, in the sense that while the client is bound to know the service, because if I want to use a service, I need to know where to look where to go for the service. These kind of service-generated messages usually have to have a prior, let's say, step in which the client registers to the service. So I am a client, I register to this particular service, and then I receive push information from the server side. And it's essentially the two previous one turned around. You have the notification messaging, in which once in a while, after I am registered to the service sends the message to the client and does not expect anything back. The other one, which is a little bit more sophisticated, is that the server sends a message to the client and it expects a message back. That could be just an acknowledgement that you have received the message from the server, or it could be something more complicated in which you are really starting a conversation and a process with a server. And this is the so-called solitary response. So variation of all these, it's something like 4 types of exchange patterns over which you can play and develop a number of applications. Yes, and that's the generic syntax. So we have seen the previous one already. It's essentially the way that we have been implementing the stock price request response. So you have an input, an output, and an error. Again, here it's from the service point of view. So you are waiting for an input, you are providing an output or a message error. And so you can easily understand in this, let's say, general syntax, also the other, how you can group together. So all this has to do, essentially what I'm saying, in very simple words, is that there are 4 types of way in which you can write this operation. Request response, solitary response, we just have first the output, then the input. One-way operation in which the server is receiving an input, notification operation in which the server is only sending an output. So that's for the exchange patterns. Easy. And these are the one that you will play with. So to summarize this abstract part, that's the color are not great. That's how it works. It works from the granular atomic individual parts, which contains the data types. They are, let's say, joined together in messages. Messages are joined together in operation, and all these are combined in a specific port type that allows the second part of the game, which is the service implementation, the concrete implementation. So let's go into this one. What are, you will find at the top level of this hierarchy, behind here, the so-called binding. This is where you essentially wrap around a port type, which was the higher abstraction of the previous layer, a name, typically, and then you start to be a little bit more specific about the kind of transport that you want to implement. So here is an example, again, of our running example. The binding is that we say that we are going to bind all these things on this particular name, so it's just the name. And then you start to have more information. First of all, you have to define what kind of SOAP you're going to use. Are you going to use an RPC SOAP, or are you going to use a document style? And that's how it is said here. This is in particular, in this case, is the document one. And then you go into the specific of the operation. And it's the same one as before, so that's why I'm running a little bit fast. The first one is the name, the document style binding on SOAP, so this is how you tell it. And then you are going to actually get information about, okay, in particular the name of the operation and a specific, let's say, a specific URI where you can find this particular operation. That's the operation, and also how the body of the SOAP message that you are going to use, because you are declaring here that you're using SOAP, how is going to be encoded. In this particular case, is going to be encoded with an internal, let's say, with a personalized XML schema for the data. Or you can use the internal one made by SOAP. But in this case, you are saying that you're going to use this particular schema, which is external, both for the input, for the output, and for the default, which is in our case is the only thing that it's out there. So the first thing is how you're going to connect with your particular transport protocol, in this case SOAP, literal, and with a specific data schema. Second, you have the port type, which defines the specific network points, the address of the location, and then you wrap this one into a service. So to have a kind of a diagram of what we have been talking about is maybe you can see as following. The first abstract part is essentially of a data schema and message schema and exchange patterns. And you have essentially how your service looks like in terms of interface and messages. Then you have and this goes all the way to the port type, essentially. Then you are, with the second part, you are flexible enough to define one. In our example is only one, but you can define for the same port type a different numbers of particular binding. Binding which refers both to the transport layer and to the encoding of the data of the SOAP messages, and then to the particular transport protocol. For instance, you can use one on SOAP, one on HTTP, and one using simple mail protocols. Again, that's something that I'm going to stress a little bit because it's one of the things in which SOAP web service or big web service differs from the REST web service. They differ also in many other things, and we will go through that. We will recap all the pro and contras, what favorite things and things that they are not approaching well. But this is one key factor. When you have a particular implementation of a service through the WSDL specification, you can expose, let's say, the same service, which is a collection of endpoints, of ports, in various ways to the outside world, and in particular to the clients. The example here is that this one, for instance, goes through SOAP HTTP. So this is a really, let's say, SOAP web service. But at the same time, you also can decide to send it in a different way, like, for instance, in a RESTful way. So SOAP web service and WSDL in particular allows more flexibility. You can have different implementation of the same service, which is quite useful in many applications. Think about services which can be addressed or called from different environments, from a web environment, from a mobile environment, from a standalone application inside an enterprise. And that's the word of the previous picture. Okay, how do we use WSDL? Again, here the ideas are very simple. The mechanism that the developers use to implement web service logic within their application is by using the so-called proxy classes, and in object-oriented programming in POSIX objects. Now, you have all the text in the slide, but what I will use is a diagram, and the text is related to this diagram. The machinery, the middleware that is out there available for SOAP services based on WSDL is pretty sophisticated at the moment, and is again has probably a better support at the moment than REST services, although now REST services are catching up on this one. And the implementation is, if you think about it, nothing new. Is coming from previous experience that we have been touching and presenting in the initial part of this course when we were starting to talk about a summary of distributed systems. So it's very similar to what you have in remote method calling in Java, in remote procedure calling. You have to start always somewhere. So let's start from the server side. The service provider has some kind of implementation of could be pre-existing, so legacy system, or could be something that you are developing ex novo from scratch. You essentially do two things almost automatically nowadays. You create the web service interface in your server, in your machine, and the same proxy engine also automatically from the reading of from the code directly of your implementation creates a WSDL file out of it. This WSDL file has to be put somewhere accessible. It is on your server. It could be on some kind of repository like UDDI. We will briefly see about them in another lecture. Anyway, it must be available, and it must be in a specific point that the various clients can download it. So it must be in URI. At this point, it's the client comes in. Whatever it's the client has to have access, so has to know where it is, this WSDL file. If it is an internal, let's say, service within an enterprise, there is no problem. All the services are put in a repository and they are there. If you are on the World Wide Web, you have to have a mechanism to discover this service. But this is a different problem, is the discovery part. Let's say that you want to use this particular service. You just download the file, and an internal engine is capable of using all the power of the XML specification. So it can understand, first of all, if it is a well-formed document, and this is something that needs to be, otherwise it cannot be processed. But that's, as we know, very limited kind of usage. The second part is the most interesting. It has a WSDL file which has been generated under a specific schema, so it can validate the schema and therefore can be able to implement the schema, so it can be able to do something with it because it can validate and understand it. So this is the kind of code generation that is made possible by the schema, by the validation part, okay? Because since you know that this file is written in this particular protocol, you can write this automatic code generator that generates the stub on the client side. At this stage now, from the client application, you can, at the design time, the moment we are talking at the design time, you can call this service as if it was really local, because you have this stuff, this proxy. In reality, as you can imagine and you can understand, the messages will travel through the net and will reach the other, the service provider, and get back eventually the response. So that's the overall picture of this architecture. Nothing else, I would say. And this is the no, this is the code generators. There are a number of them. We will use the one that are typically developed for Java, but there are code generators on the client side and also on the server side that are developing and automatically generating the WSDL file in all different development environment for the moment. And they work because WSDL is well suited for code generators, because it has a very strong expressiveness, meaning that all the information are there, all the information are coded, all the information are made available in a machine format, so the machine readable format. State of the art of WSDL, and we are almost finished. As I was telling you, there has not been a big evolution. There has been some evolution from 1.1, 1.2. The major, let's say, evolution development has been from 1.2 to 2.0. A little bit of information, but in particular, I think that, as usual, a diagram explains much better. As you see, the implant, the generic design has been maintained. So you have the separation about the abstract part and the concrete part. There has been a little bit of renaming. So first of all, types and messages has been united in one single element. So it's even more simple than that, than the one that I have been telling you. Now, at the moment, both versions are still available. So generically, you are able to cope with both of these versions, but these differences between type and messages has been glued together in one specific element. There has been a small change in name, port type, and interface over here, and here is just again small changes in names. So why they have been doing from 1.1 from 1.0, if I have to go, is essentially it's a better conceptual model of there has been some experience in this period of time, and it's a better conceptual model for approaching, but nothing significantly different. So that's why I've been not changing the presentation from 1.2 and 2.0. Outlook of WSDL. It's very popular. Why it's very popular? Because one of the reasons that of the popularity is that is nothing new, is not a revolution, it's just an evolution of the interface description language model that has been used for many years before. The differences with respect to the interface design language is that nowadays most of the interaction occurs on the internet, so there is a good support for that. Is using XML as syntax and type, and also type system, so it's open and extensible, so it's very powerful. And the various things that we have been talking, the possibility of grouping operation and different options and different possibility to have the same services in different addresses and in different protocols. Great advantage is exactly this evolution part, so it's very simple and straightforward to wrap legacy systems that are present in enterprises to this new environment. So it's a very powerful tool together with the SOAP protocol about communication to really integrate enterprise application among themselves, and it's very automatic, the translation from previous existing ID interface description languages and WSDL. So everything is good, and in particular it is good. It has been used quite often. Now it is also extending, and there are some work that are being doing right now of extending WSDL also to REST. So it's quite straightforward also to include REST in this one. As you know, that REST in the first evolution was missing this kind of description. So the description is a little bit, let's say, open. Like with this one, you can make it more stable. And this is good news. That means that you can use very probably and very soon, already, WSDL to describe REST and to include REST. So you don't even have to use a SOAP as a mechanism. You can use you can even be more open. if one wants to say something bad about WSDL, it's the following. Essentially, it is not made or designed for businesses. It's really designed for individual services. What I mean about that is that it cannot capture some important elements of the business application of commerce or business to business, which is the procedure. So normally, business application, they implement a process, a procedure, a workflow, or a business process. That's what it's the name that he used. WSDL does not tackle this problem, and it's left for this problem of conversation, so sending in a coherent way a number of messages so that at the end you have the implementation of the process, or also another term which is used is choreography. The conversation or the composition is mainly when you have a sequence of well-defined steps that you have to implement in your process. The choreography is more related to the fact that sometimes you have a number of users that has to cooperate in a particular way with some particular roles. First I have to call this one, then I have to call another one. So it's not only two services, it's really a group of services that has to be used in a particularly choreography. It's a terminology that comes from theater, and it really means this one, when you have a number of people that have to do something together to produce something. And this is not tackled completely by WSDL, so you have to have other layers on top, and as a matter of fact there are a number of these. Beeple is used to compose services, and also we have coordination and choreography specification to be able to specify these higher level approaches. At the WSDL level, if you want to do a business protocol, all the work has still to be done manually, okay, and not automatically. That's the end of the day things. So that's it for WSDL. So as I was telling you, it's not a big lecture. This one is only on. I prefer to tackle one protocol at a time, because putting them together it's complicated. Let's say it's also boring. So if you have any questions on this part. Just a few comments. SOAP, we will essentially, about the SOAP protocol, we really will not touch it, essentially. We will show in the laboratory how it looks like, how the system works, and we will maybe be able to look at some of the messages just for the sake of curiosity, but really you usually don't want to go at that detailed level of interaction. WSDL, on the other hand, it's something that is in place more useful, because it's something that we will look more often when you are documenting. That's also the point. When you are documenting any particular service-oriented application project that you're doing, WSDL is one of the documentation part that you always collect, because it's something that people can understand, even if it is essentially done mainly for the machine point of view. It's something that you really can use as a good way of documenting your application. Okay?
Sure. For the commercial and business side, we should not use WSDL, right? Because you said that for the commercial or business side, we should not use the WSDL.
No. I didn't say that we should not use WSDL. I say that it's not really supporting too much this part. So when you have a business, so as you probably have seen now, WSDL is very good to describe individual services. The one that we have been using as an example is a very simple one, okay? You can imagine more complex service with a number of operations, with many different parameters, but essentially it's done for this particular type of, let's say, granularity of the service. what I'm saying is that, and you should use it for business services, okay? What is not good at, because it's not the purpose of it, is to being able to describe complex interactions between services in a business settings. Usually in a business setting, you are combining a number of services together for a purpose, implementing one kind of procedure for buying things, e-commerce, for doing whatever you want. And in that case, you need some other tools to combine together the different services. Because there is some logic, maybe, in this process. There is a workflow. If something happens, you have to go this way. If something happens, you have to go the other way. And this is one part inside the process. And then there is a second part, which is the choreography, where you have different operators. You have a service buying, a seller, a broker in between, other people like the logistics that need to be combined together, and then you need other design and also implementation tool. That's what I wanted to say. Okay. Thank you.